How are you? I hope you are quite well, happy, healthy, and your study is going very fine. So let's start here. We will study the two method of preparations from first is the oxidation of diols and second is that hydrolysis of JM diols. From these two preparations, from this two way, you will get the either aldehydes or ketones. Okay. Student, once you understand, please like, share, and subscribe the channels. Let's start here. The first we are going to understand that the from preparation of aldehydes or ketones from oxidation of first is that oxidation of diols. We can also say that polyols because suppose you have polyols multiple OH group, then we can say polyols. If 2 OH will take, minimum 2 OH will require, that is called diols. So from this way we will get the aldehyde or ketones. So it is also called as strengths. That is a very not a popular malaprade oxidations. It is also called malaprade because malaprade is a scientist who first synthesized by this way the aldehyde or ketones. This is called malaprade oxidations. Now the question is what the condition for diols or what the condition for this whole process. Condition for diols is strengths. Say what is the condition for diols? Condition for uh, diols. What is the conditions? Number one is that your diols must be uh, at least uh, two OH group should be there in the chains, right? Means if you have a diols, if you have a diols, both OH groups should be at the adjacent positions, right? Second, either you have a two ketonic group, okay? Either the two OH group or two ketonic group. Third, either one OH and one ketonic group should be there. And fourth and most important, both should be syn positions, not anti. Anti is also formed, but it is not a stable. So syn is formed. Okay. So that means syn. What I am telling you, vicinal diols. That is the vicinal diols, right? So that is the only cis vicinal diols. Okay, cis vicinal diols. You should be there. So what I am telling you, at least two OH group, double bond, two ketonic group, one OH, one ketonic group, and fourth is the not anti, it should be syn positions, right? Now see there, what I'm telling you. Now my questions to you: which of the following will not be oxidized by HiO4? Because oxidation of diols or polyols is done by the HiO4. That is the periodic acid. This is the periodic acid. So the oxidations of diols is done by the periodic acid HiO4. Correct? Now the question is, now I give the questions where your concept will clear. Which of the following will not be oxidized by HiO4? What I write here questions? Which of the, see, which of the following are not oxidized by HiO4? You can see here. First is that CH3, CHOH and CH2OH given. The second I write here CH3, C double bond O and C double bond O CH3. Third is the here third is that CH3, C double bond O, CH double bond O, and fourth is there CH3, C double bond O, CH, NH2, CH3 is there. And fifth is here there is a like here I write the proper way the compound like. Okay, so here is that. Okay, I write here You can see here. So in the fifth is that, okay, I write here, right? And here is that oxygen, okay? And sixth, I write here CH2OCH3 and the CH2OH. And seventh, I give you the options here C double bond O, OH, CH2OH. So your concept will clear here. Which of the following are not oxidized by HIO4? See, the two OH attached on the same adjacent position, first and second. So that will oxidize by HIO4. Second, the two ketone group here, that will also oxidized by HIO4. Here is also two ketone group is there, that will also oxidized by HIO4. Here is ketone group, that will also oxidized by the HIO4. CO, CHNH2 should be there. So one position CO, second position NH2 should be there. And fifth is the, that also will be oxidized, right? And sixth is there. Student see, sixth will not be oxidized because it is not a group like that. One is OH, second is OCH3. So sixth will not be oxidized. And seventh is the acid strain. So seventh will not be oxidized too. So sixth and seventh will not be oxidized by HiO4. Clear? So I hope you understood which compound will oxidized or which compound will not be oxidized by HiO4. Okay? Why this compound will be oxidized? We will study in the next in the reactions like that. Okay? We will understand this concept. Okay? Here I am not going to describe the mechanism of this reactions because NH2 group will convert into the OH group by HNO2. HONO. That is called HONO. Means when we take NaNO2 plus HCl, you will get the, that will convert into the OH group. You study in the amine. So ultimately it will convert the OH form. Therefore it will be oxidized. Okay. Now see here students. I write the example. Then you will understand here. CH2OH and here is that CH2OH. Okay. And when we'll take the HiO4 in the very short manner, you can write like that. Otherwise, every time it is not possible to draw the mechanism, to form the mechanism and write the products. It will take the time. Simply you write here, once bond will break and you write the OH here and one OH here. So what happened? Can I write here CH2OH, OH, okay, for this compound. Similarly, we can write here also CH2OH and OH. You know, students, in the one position 2OH group is there or 3OH is there. That will dehydrate here. That will heat himself, and then what happened? The compound will form the aldehyde. Here is also what happened? That that will form the aldehydes group. Okay. So either the 2OH group means aldehyde, 3OH group means acid will form. So here the 2OH group aldehyde will form. Okay. So I hope you understood here. What will happen? Just in water will lose. Always water will lose. Correct? Dehydration will happen. And the aldehyde will form. One more example we'll take here, students. 4-5 example we will study here. So on the basis of iodic acid reaction. CH3, C double bond O, CH, OH, CH2, C double bond OH. See what happened? Here the, when we'll take the HiO4, one here, okay, from here, right? So now we understand here. Students, here will not be oxidized because the aldehyde is there. So either the ketone alcohol or two ketones or two alcohols. See here. So what happened? Once the bond is clipped here, here you put the OH. Here you, the two bond is clipped. Here you two OH group you write there. So I write here CH3, C double bond O, OH. You can get the acid. Now we talk about this compound. Here is the CH, OH, and here is the bonds. So what you will write here? Okay. So CH2, C double bond OH group is there this side. Okay. So students, see here. Here bond will not be clear. Here will not be clear because CHOH and not anything is there. So understood, only one bond will cleave here and OH group. Understood, na? Here will not be bond will not be cleaved here, will not be broken here. So only this bond will be cleaved. So what happened? The 2H group is there. So it will supply, and then you will get the formal aldehyde like that. Okay, CH2 C double bond O H group like that. You will get that one. This compound, and second aldehydes acetic acid. You will get that. Okay, students. One more example I give you, and then you tell me what would be the product here. Okay, See here, students. I write here. See here. That is the OH. Okay, both have same position should be there. It is mandatory to to react the HiO4. Any compound react with HiO4, the cysteine position should be there. So HiO4, what happened here? Bond. So I write here 1, 2, 3, 4, 5, and 6. Okay, so one OH will come here and one OH will come here. So what happened? C double C OH, and second is there CH2 third, fourth, fifth, and sixth OH and OH. So the 2H group there, here is also. So heat will supply, water will lost, and C double bond O, H, CH2, 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 C double bond OH will form. Okay, so this compound will form. One more example, students. I write here ketones, fructose. I write here. You tell me the how many acid you will get that, how many aldehyde you get that. You have to tell me that how to obtain the product. CH2 OH C double bond O. Okay, and here is the OH H. I write here H OH H OH, and here is the 1, 2, 3, 4, 5, and CH2 OH. We have supplied here HiO4. Can you tell me in the how many product you will get that, and what product you will get that? Students, see here. First bond will be oxidized from here. This bond will be cleaved here, and second here is also, right? So here will be also. So what happened? Here you will get that carbon dioxide. Am I right or not? Because the OH, what I'm telling you, this point you will get the carbon dioxide. So here you will get that carbon dioxide. Am I right? Because the C double bond O, OH you will get that. Heat will supply, water will lost. So CO2 you will get that. Correct, na? Okay. Here you will get that formaldehyde, HCHO, right? Rest 1, 2, 3. So 3 moles of formic acid, 1 moles, and 1 moles. Formic acid 1, 2, and 3, right? And next for here you will get that formaldehyde. Okay, so 3 moles of acid, 2 moles of formaldehyde, and 1 moles of carbon dioxide. 1 moles and 1 moles, 2 moles of formaldehyde, 3 moles of acid, and 1 moles of carbon dioxide. You will get that. Understood or not? Clear? Okay, student, one more question I give you, and you have to tell me the how many moles of HiO4 you will take for these reactions. CH3O, CH, here is the CHOH, 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 okay, and here is that CH and CH2OH. So you have to tell me how many. So when we'll take the X moles of HiO4. Now my question is, what would be the value of X? What would be the value of X, students? Option 1, 1. Here is a 2, C, 3, D, 4. How many moles of HiO4 you will take for this reaction? See, students. One thing should be clear. Here is no oxidation will take place. Also, here will not be oxidation will take place. Why? Because no consecutive OH group is there. Okay, so only HiO4 will work here and only work at here. It means 2 moles of HiO4 will require for oxidation to these compounds. Okay, so I hope you understood here. Student, don't be confused here. One thing I am telling you, CH3, CHOH, and the CHOH I write here CH3. And if I use here H plus heat, you will not get the same product as you have got that HiO4. No. This is the different reaction which is called pinacolone reactions. And you study in the alcohols. Okay, so I have taught there with the mechanism. So how to obtain here? You will get that CH3, C double bond O, CH2, CH3. So you are not getting here the same product like that. Okay. Now see what the mechanism of HiO4. How the HiO4 will work like that. with the any groups. So we understand now the mechanism of HiO4 with the diols. See here students, CH2OH, and here is the CH2OH. We have taken here HiO4. So I draw the structure here, double bond O, and O negative OH. Okay. See here is the lone pair. Here is the lone pair. So what happens, students? The lone pair will attack here. The bond will turn like that. Okay. So similarly, here it will first one step by step. Okay. Step by step we'll go there directly. It will attack here. Exactly, bond will turn. Okay. So now I write the product here. CH2. This is a transition state. You will get the cyclic state here. O H O H I. Okay. O negative, O negative, O negative, and OH. So one bond here and one bond here you will get cyclic state. Students, now this is unstable, so proton will transfer here. Here the proton will transfer here. So that what happened? What product you will get that? So you get that CH2, CH2, O, and here is the, okay. So OH, O negative, OH, and OH you will get. Now students, the bond will turn here, bond will clip here. So how to, when you supply the heat, it is a transition state, very strain is there. So in this, when you supply the heat, what will happen, students? Bond will turn here. Okay. Here is that. So bond will cleave here like that. Okay. And you will get that CH2 double bond O and CH2 double bond O. This is the way every time you are getting the product exactly in same way. And then you are getting here HiO3. Okay. So I hope you understood how you are getting this product, how you are obtained the product. Exactly this is the way that you are obtained the product. Okay. So I hope students you understood this whole mechanism of iodic acid for iodic acid. Now we go to the second method of preparation, and second method of preparation is what? This is the from gem dihalides. Second, from gem dihalides. Okay, from gem dihalides. See, gem dihalides and terminal dihalides. See, students, when we take the gem dihalides means first position, two halogen is there. So when we take the aqueous QH, student, it follow the SN2 mechanism, as you know. So then what will happen? The compound will form like OH, and just I said that when the two OH group attach on the same carbon, then the dehydration will take places and you will get the formaldehyde. It's depend on the gem position where they attach. Second positions, suppose your group is here, chlorine and chlorine, and the aqueous QH we have taken. Then what will happen? Students, see that the two OH group, when the two OH group attach on the center, on the mid positions, then the ketone will form. When the three OH group attach on the last carbon or first carbon, then the acid will form. Then the dehydration will happen, water will loss, and here you will get the ketone you can obtain. So therefore, I have written here from gem dihalides. Okay. So remember that here I write one thing. What I write here? The terminal gem dihalides. Terminal gem dihalides. You will get that what? Aldehydes. And non-terminal you will get the ketone. Have you seen that? Non-terminal we have got the ketone, and ketone, and terminal we have got the aldehydes. Students, any doubt if you have regarding this whole topic, we have done that. Please, you send me your doubts from the any book, any modules. My mail ID, you have a mail ID in the every lectures. I mention the mail ID. You go and write the questions or screenshot the questions or whatever you can do. You send me. I will mention your doubt in the next lecture. Thank you. Have a nice day and take care of yourself.